Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to Cloud Test Lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
Let us say you have written at this level. So this level, if you have written at this level, all these lines are executed by your main thread only. That means this particular line also will get executed by your main thread. And this thread, this method call will provide information about the current thread on which it was called. So currently this was called by the main thread, and it will provide information about that particular thread only, and the return value is a thread class, thread object, I'm sorry. When you call this one, this line will be executed by a thread, and the return value on the return, it will be going to provide information about that particular thread. So this is very important one when you enter into threading programming, because you need to know which thread is executing that particular method or code. Once you have created, yeah.
Where will you be executing this particular statement, the current thread?
Main method. I'll show you.
Yeah, when multiple threads are running.
No, 1 second. We'll talk about remaining threads later, but first of all, we're discussing only about main thread. Okay. So once you have created, let us go and take a look at. I'm creating a package, com.threads, example for main thread, public static void main, I need that. So inside my main method, I'm going to write thread dot current thread method. This is a static method I can easily access by using static class name. This will be going to return, you can see the syntax, this will be going to return a thread object or thread reference. So normally when you start executing any line within your main method, just now only we have mentioned that this will be executed by a thread called main thread. So this statement thread is also executed by our main thread only. So you will get a reference to your main thread which has created by your JVM. Let us go and print that particular thread. We'll see what kind of information we'll receive. I'm just executing this line. You can see that it has provided as main thread information. This is just a static content that I have provided. And on the right side, it has provided like thread of main 5, main. Thread of main 5, main. So within this parenthesis, it has provided information about your main thread. The 3 parameters it has provided. The first parameter is name of the thread. The second parameter is priority of the thread. We'll discuss about priorities later. And the third parameter is thread group. Whenever you print the thread object or thread reference, you will get such type of output only. Even if you create a child thread also, you will get such type of information only. So the 3 parameters, what it signifies is, first one is the name of the thread. So currently your name of the thread is main thread. The next one is priority. Priorities we'll discuss once after covering 2-3 topics. So in today's class itself, we'll discuss about that one. And the last one is thread group. So currently your thread group name is also main. Thread group is a data structure which is a collection of threads. That means your thread group will be going to maintain all the threads. So it will maintain your main thread and it will also maintain your child threads as well if you have created. Currently, I have only one thread, which is my main thread. And you can also create a thread group, but that's not a preferable one, because whatever the thread group that your JVM has provided, you can just make use of that and you can create any number of child threads, and those threads will get added to your thread group. So this statement, thread.currentThread, this is a static reference which was available from your thread class. Let us take a look at the API first. Java P, java.lang.thread. These are the methods that are available with respect to your thread class. We have started learning API from last topic onwards, from exception class also. From exception class itself, we are able to identify all the methods and how to access those methods and how to use the objects that we have learned. So from now onwards also, we'll just learn how to use the API. So with respect to multi-threading, we'll see how to use the thread API and some other APIs with respect to thread. And the next classes, collections or IO streams, those are also, we just need to understand how to use the API or what is the purpose of method and how and where exactly we are supposed to use those method calls. You can see that these are the methods that are available with respect to my thread class. There are a lot of methods available. At least we'll discuss 10 or 12 of them, which are very much important for our threading concept. You can see that there are plenty of constructors available, and these 3 are public, static, final. static final variables, and you can see that they also followed the same standard specifying in capital letters. And our current thread method, public static, forget about native, java.lang.thread, and the method name is current thread. This is the method that we have used currently. Currently, you are calling this thread.current thread in a main method. Let us assume that you have created a child thread and you are in the run method. When you use this call thread.current thread, at that time, it will provide the information about your child threads. When you're trying to execute or use multi-threaded programming, you need to understand like which thread is executing that particular method or the current code. So for that purpose only, this particular call, current thread static call, is very important. The next important method with respect to thread class is sleep method. These are all static methods. That's why we were discussing earlier. Later we'll go to the thread lifecycle. Sleep method, this is also a static method from your thread class, which is used to inform the current thread to sleep for certain time. Thread dot sleep of 1000. Time, it will be specified in milliseconds. See, currently we are not working on any user threads. We will create a user thread once after learning thread lifecycle. So when you say thread.sleep, this sleep method, so let us say if I have written the thread.sleep method here in our main method. Let us say 5000 milliseconds, which means 5 seconds. Take a look at the API for sleep method. Your sleep method throws one exception, which is interrupted exception. And this interrupted exception is a checked exception. So what is the standard for checked exception? Whenever a method throws a checked exception, and when we are trying to use that particular method, you are supposed to handle that particular exception by using try catch block. If you are not able to handle, so currently you can see that here the compiler is giving an error. The reason for that is unhandled exception type interrupted exception. So this is a checked exception and you are not handling this exception. You have two options. The first one is either you can handle the interrupted exception at this level, or else you can specify that I am not able to handle this exception and I want to throw this back to the caller. This is the second way that you can avoid handling the exception at calling level also. I guess we haven't discussed about this one in our exceptions layer. Either you can handle at this level, or else you can simply throw back, just like your abstract references. If you are not able to provide the definition, you can simply specify that class also as abstract and make it as abstract class, and it will be done by all the concrete classes. In the same way, if you are not able to handle the exception also, you can simply throw back to the caller. Currently, that's what I have done here. main thread completed. So currently you can see that thread.sleep of 5000, which means it will sleep for 5 seconds. You can see in the output a gap. Let us execute this code. You can see that my JVM Java is still running and it has printed the information after 5 seconds. Let me execute one more time. See, the thread is sleeping now. Whenever you say sleep, whoever will be going to execute this particular line, they will be going to sleep for that particular amount of time. So currently you are asking the main thread to sleep for 5 seconds. The reason why we have used the sleep method. See, your CPU cycle, once you have created multi-threaded programming, let us say you have created 10 threads. 10 threads you have created, that means you have 10 paths of execution. So once you got the CPU cycle, it can only assign to one thread and all the remaining threads are supposed to be in waiting status only. So if you want to switch the CPU cycle from one thread to another thread relinquishedly, you can just put a sleep method on that particular thread and you can ask the thread, I don't want the CPU cycle right now, or else you can say, I'm waiting for some resource, or my work needs to be started once the stock information has retrieved. Stock orders or the automatic orders placement will be done only once after receiving the update information from the stockbrokers. So until that time, I'll go on sleep. So for that purpose only, we can make use of the thread.sleep method, and sleep method is a static method and you are supposed to call on class only. So static methods, static thread related methods, those are all work on the current thread on which those statements get executed. Each and every thread will consist of a life cycle. In the sense, the thread will get created first. So let us say if you are creating some child threads from main thread. Once you have created a thread, it will enter. See, the purpose of creating a separate thread is to have separate path of execution. Once you have created a thread, you will write some business logic code. Business logic code within your run method. So when the method has started executing, when the run method has started executing, that means your thread got the CPU cycle. And let us say once it has entered into the run method and you are able to understand that you are supposed to wait for some time or you are supposed to sleep for some time. So at that time, instead of wasting the CPU cycle, your thread scheduler will give the CPU cycle to another thread. So whenever, let us say one thread has started working, and within the code you have mentioned that sleep for 10 seconds. So that means You are not going to use the CPU cycle, whatever that got allocated. So instead of wasting that particular CPU cycle, your thread scheduler will be going to contact the thread group, which will maintain the collection of threads. So your thread scheduler contact the thread group. It will contact the thread group and identify, are there any waiting threads available? Yes, if there are some waiting threads available, it will be going to hand over the CPU cycle to that thread and it will start executing that particular thread. So to maintain all this information, or when to start a thread, or when to enter into blocking or waiting status, or when to terminate a thread, so all kind of stuff is placed in thread lifecycle. To create any thread, to create any child thread, Java has provided two options. The first one is create a subclass of thread class and override run method. The second way is implement runnable interface and provide definition for run method. So in either cases, you are supposed to provide the definition for run method only. The first case is extending a thread class and writing a subclass, and the next one is implementing runnable interface and provide the definition for run method. You can make use of any of the two choices available, and you can create your own child thread. Yeah. So let us write the thread lifecycle in a diagrammatic representation. Whenever you have created a thread, it will be in the new status. In the sense, let us say you have followed any of these two approaches and you have created a thread object. When you have created a thread object, it will enter into the new status. New status means you are not going to work on the new business logic code. You have just created a thread reference in the memory. That's it. Once you have created a thread, you can call a method which is start method. Start is used to start processing the thread. When you have called the start method on any thread, it will enter into one state which is runnable state. Runnable state. The next state is runnable state, which specifies that the thread has entered into runnable state and is waiting for the CPU cycle. So whenever a thread has started, it will just enter into a state called runnable, which means it is eligible for running and waiting for the CPU cycle. Whenever the thread has selected for running, or let us say there are plenty of threads available in runnable status and one thread was chosen by your thread scheduler. Your thread scheduler will contact the thread group contacts the thread group and identifies what are all the threads available to get the CPU cycle. So let us say there are 5 threads available and 1 thread has chosen to allocate the CPU cycle. So at that time, your thread will enter into a state called running status. Running status, at any point of time, only 1 thread will be in running status. Running status means currently it got the CPU cycle and it is executing the instructions now. Once it has entered into the running status and it started executing the instructions, if at all, if there are input stream waitings or socket connection waitings, or let us say sleep method calls, for all those cases, it will enter into another state which is blocked or waiting status. Let us say you have mentioned that go on sleep for 10 seconds or wait for some time. Whenever you specify that go on sleep for some time or wait for a resource or wait for some notification, whenever it has received such type of stuff, it will be going to enter, the thread will simply enter into blocked or waiting status. So that means there are no running threads available and this place is empty now, and the thread scheduler can choose some other threads and it can move to running status. Let us say the sleep portion has completed or the waiting time has completed, or else let us say the input stream is available now. So that means this thread is live now. This thread is not required to be in blocked or waiting status. Whenever a thread woke up, it won't directly enter into running status and it will simply place into runnable status. Whenever a thread woke up or the sleep time has completed, let us say 5 seconds has completed. So at that time, see when thread 1, let us say thread 0, let us say thread 0. Currently thread 0 is running status and you have mentioned that go on sleep for 5 seconds. So at this point of time, the thread 0 will jump to this particular place and your scheduler, what it will do, it will find out another thread which is in runnable status and it will move to running status. So currently thread 1 is running status. So when this guy has completed sleeping or when it has received the resource, it was not possible for thread 0 to enter into running status. Only he can do is he can simply go and wait on to the queue in the runnable status so that it will be again chosen by the thread scheduler and placed into running status. No threads will enter directly from blocked to running. It can only enter into runnable status. Let us say there is no running or any sleeping or waiting kind of stuff, or else let us say the same thread 0 was chosen again for running status and now it is again available at the running level. When the run method has finished, it will simply enter into a state called dead state or terminate status. Terminate means the thread execution has completed and it's not possible to start the thread again. once a thread has terminated, you can't start the thread. That means once it has reached or once it has completed the run method code, if you try to call the start method again on that, you will get an exception saying that illegal access exception, or sorry, illegal state exception. So normally a running thread can enter into terminate state only when the run method has completed. Previously we discussed about call stack. Let us say this is our main method call stack or main thread call stack, and it has started executing the program main method. And let us say from main method we are calling some other method code, create thread method. We have called create thread method, and in create thread method, this is main call stack. In create thread method, we are creating a thread object and we are starting a thread now. Whenever you have started a child thread, the child thread will get its own call stack. Child thread will get its own call stack, and the starting method for that is run method. So now in JVM, two separate call stacks are available. First one is main thread call stack, and the next one is child thread call stack. So your thread scheduler can switch between these two also, main thread and child thread. And if at all, if this method has completed and returned back to main method, and your main method can also terminate it before your child thread terminates. Let us say in your child thread, you have specified run code, and here in run method, you are asking the thread to wait for 10 seconds. So that means your child thread is in blocked status now. But as of now, your main call stack, the main thread, it is still in runnable status only. So that means it can be selected by your thread scheduler, and it can move to running status, which means it will complete the method call at this level, and it will also complete the method call of main method, and still your blocked or waiting thread, the child thread, it was still in running mode only. So previously, with respect to old versions, old JVM versions, if your main thread completes before, you might get some issues, but later they have fixed they have enhanced the code. And even though if your main thread completed before the child thread, there won't be any issues. But we should make sure that our child thread completes first, and our main thread will be the last one only.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.